Now that you have installed the Maxim Digital Power Tool GUI, you can go to your desktop and just double-click on the shortcut for the software to start it. You can also go to the Start menu and find it that way. Once you start the software, you get this first dialog box, and it has a few options over here. The first one here, it says MUX configuration, and there's a checkbox. It's not checked over here because we're not using a MUX. The reason for this is if you have a reference design that is using multiple devices, let's say, I don't know, 12 or so or more, and you have conflict with the addresses between the devices, then you can elect to use a MUX in your design to get around this issue. And in the installation directory, you'll find a document. I'm going to show it to you over here. There's an application note called Multiplexer Application Note, and basically it goes through the whole process of how to use a MUX. The one used here in this application note is the Maxim 7358, and if you read this thing and you need to use it, it'll walk you through all the different steps. The next one is address 0C. Address 0C typically is used for alert response only. So we have this checkbox over here to skip scanning for this address. If in your case you're not using it for alert response only and you might have a device connected to that address, you can simply uncheck this box and it will scan for that address. And lastly, we have clear faults. All the devices that are supported by the software were done at different times, and some of them do not comply with PMBUS way of identifying a device. PMBUS standard says that IC device ID is the way to identify a device. It's a command, and it returns the name of the device, and it's a read-only command. Some older devices used MFR ID or MFR model, and for that reason, because the software supports multiple devices, and if you have all these devices connected at the same time and you go in through the scanning the bus and sending these commands, if a command is not supported, then you might get a fault. So for that reason, we put this feature over here to clear the fault at the beginning when you start the GUI. Any subsequent usage of the GUI, like if a fault happens, it will show up. This is only sent at the beginning. Also, I like to mention that for some devices we elected to bypass this, even though it's selected here. So don't be surprised when we click OK if there is something that is showing a fault. For example, I believe the MAX15301, the send clear fault is not done. Next thing here, you see this checkbox. This only happened if you are using MAX15303, 730 or 734 devices, and the reason for that is these devices they're identified similarly, so you actually don't know which one you are using. For that reason, we added a software fix telling the user to choose which device they are using. So in my case over here, I'm using the MAX15303. So once I select that, I can close this, and then the loading continues. Okay. See, as I mentioned, it's showing a fault here for MAX15304. So I can just hit clear and clear it over here. This is what we call the dashboard, and in the dashboard basically you get a tab for each of the devices and the address. So in the tab here you see 012 hex, that's the address where the MAX15301 is connected, and so on. Like for the 303, it's connected at address 30, the 743 at address 50, And the MAX25304, this is like 2 rails for the same EV kit for address 5A and 5B. And then in the dashboard over here, you look at there's the name in here on the side. It tells you what each of these parameters mean. So you have the address, the product name, the firmware version, if it applies. Some devices do not have firmware, so you'll have a not applicable on it. And then hardware enable, if it applies, you'll have the checkbox in there. If it doesn't, then you won't see it. And PMBUS enable. What this is basically hardware enable. You're using the switch on the board itself to enable it. You can disable it via hardware over here, so you see that it's not enabled, and you can enable it via PMBUS if that option is supported. So if I enable it via PMBUS, you see that it's enabled and power good is good. Okay, so I'm going to go back to, oops, hold on. Okay. Next you see telemetry parameters. You have your input voltage. That's typically all of these are powered via 12 volt, more or less. Output voltage, that's the read V out, and output current frequency, if it applies. Some devices do not have this command, and you can see that all these commands over here, if you hover over, it tells you what's the exact command in PMBUS command for. Here, like this one here, it's a read frequency. This one is internal temperature. So anyway, this is the temperature, the external temperature if it applies. Duty cycle, same thing. If it applies, it'll be there. If not, then you'll see not applicable. We already covered this one. If the device is enabled, it's green. If not, then it'll be red. Same thing with the power good. And then if there's a fault, then you'll see the fault indicator here. Typically with faults, if it's green, there is no fault. If it's orange, it's actually a warning and not a fault. And if it's red, then it's a fault. And we have a clear faults here for each of these where you can clear the fault. If it's a simple fault, you can simply click on it and it will clear it. But if it's something like, you going over the max voltage or under the min voltage, then you'll have to fix that before you can clear it. Simply selecting clear will not do it. Here you see the vout command, so it basically tells you what the vout command is set to. And then these are like various delays, and these are explained in the either the user guide for the specific device or the PMBUS specification. Over here on the right-hand side, we have the few plots, basically the output voltage, and these are by color over here, and I'm going to stop this, hold on. And it tells you like each one, like the green one over here is for MAX15303, so you can see it over here, and so on. And you can start and stop. This is as the communication is ongoing, constantly reads the voltage and output it over here. The GUI as a whole is device centric. So whatever you see in the GUI, all these values, these are not static values that are saved somewhere. It's basically what's being read from the device itself on the board. Over here, the system sequencing plots, basically these have to do with the delay, on delay time, on rise time, off delay, and off fall times. And if you change these values, you can actually see these plots changing. Next, we have a bunch of features over here. Let me try to cover everything here. So we have a bunch of buttons over here. The first one, search for devices. It's available also, search for devices, sorry. If you do a search for devices, basically the GUI kind of like restarts. It will scan from scratch again. It'll scan the addresses from 1 to 127, and we'll find the same devices here. I'll do it just so I can show you. Again, it's asking me about that device. And then everything comes back up. The next button is Save Configuration. What this button, hold on. I thought this was not working. It is. The Save Configuration basically saves all the a configuration file for the devices. And the save configuration that we have here on the dashboard basically saves one configuration file that contains the data for all devices, for this one, this one, this one, and this one. The load configuration button here will load the file that has been saved, and if the file is saved from the dashboard, it will load it for all the devices. The store user all, this is if you make some changes and you have multiple devices that are connected and you want to store all devices at the same time, you can click Store User All and it will store the data for all these devices. Of course, the device has to support this command, otherwise it's not going to be useful. Next one is Stop Communication. As I mentioned, when you have the telemetry from all the devices here, you see the values that are changing because you're constantly reading from the board. If you click Stop Communication, then everything stops. So, and you can notice that none of these values are changing right now. If I do Resume Communication, you will see the values changing again. Next is the Broadcast Command. Broadcast Command is basically, let me click on it first. Okay. The Broadcast Command, if you want to send a command, a PMBUS command, to multiple devices via address 0. Of course, the devices, they have to support the broadcast command for this to work. For example, let's say you want to send the value of 64 to operation to all these devices. If these devices support broadcast command and then you send this command, then it will send it to all of them. If a device is not supporting the broadcast, then nothing will happen. So I'm going to close this. Since all these devices are PMBUS devices, one of the things that I would recommend anybody that is working with the PMBUS is read the PMBUS standard document. And you can get the document from pmbus.org. Once on the website, you have to be logged in order to download the PMBUS specification documents. In case you don't have an account, you can always register and then proceed to download the documents. You can also download the SMBUS specification documents, which shows what the PMBUS is based on as far as transport for sending bytes, sending words, and so forth. I have all these documents already downloaded, so I'm going to close the website here, and I'm going to show you these documents. For the PMBUS specification, there are 3 parts. Part 1 is general requirements, transport, and electrical interface. This is a really short document, so I would recommend you go through it. Part 3 has to do with a different protocol, the AVS bus, and it was added a few years back. For our demo today, all the devices that we're using support PMBUS only, so there is no need for AVS bus. But in case for the future you're using a device that has AVS bus, you might want to go through and read this. The main documents that you should definitely use and read is the Part 2, which has all the definitions for all the different commands. I have scrolled down here to the appendix here, command summary. This table here shows you all the commands available. the command code for each command, the name of the command, and then it shows you the SMBus transaction type. Is it a write? Is it a read? Is it a send? Or it doesn't apply. It also gives you at the end over here the size of each command. Now in this document, for each of these commands, there is a section or a paragraph that explains that command in details. It goes down even to the bit by bit, and then it gives you a limitation, what kind of format is it a direct format, is it linear, and so forth. This is the SMBus specification document, and it's the protocol used for communication between devices. And I can show you over here just an example. If I pick one of these commands, okay, if I look at write byte or write word, it has an illustration of how the whole command is constructed based on the start bit, address, command, and then the data. Also, you can see down here, this is write word protocol, and this is write word protocol with packet error check-in. So you see the packet error check-in is tagged at the end. So it has an explanation for all the different protocols for word, byte, for block, for process, and so forth. So definitely a good read. This document I have here is the PMBUS command set user's guide for one of the evaluation kits I have here, the MAX15301. And in this document, it lists all the commands that are supported, and then it shows in details what each command is. The format is as follows. You have the command name, and then you have is it a standard command or Maxim specific? Gives you the command code, number of bytes, the SMBus transaction, is it lockable or not, the data format, unit of measure, and the Maxim settings in this case. So if we take a look at, for example, vout command, you can see it says it's a standard command. This is a standard PMBUS command. It gives you the command code. This is the same as in the PMBUS standard. It's always 21 hex. Number of bytes, it's a read-write. It's a word because it's 2 bytes. Is it lockable? Yes. And then it gives you the format. Units is volt, and the factory default is 1. It also lists a section in the PMBUS specification where this command is explained more thoroughly. Besides standard PMBUS commands, there are commands that are manufacturer specific. For example, you see over here we have the restore maximal. This is a Maxim specific command, and it's explained over here. There are several of these commands in each part. Another example is strap disable. It's a 2-byte command, and you can see the definition of each of the bits over here explained. Now that we're done with these documents, I'm going to conclude this video, and in the next video we're going to go over the separate tabs for each of the devices and go through the functionality.